Let's talk about subtracting mixed numbers. One of the things you should notice with the mixed numbers here is that we have different denominators here, and you cannot subtract fractions when the denominators are not the same. So this is a 3 and this is a 6, so we can't just subtract the numerators, the top parts there. So what I'm going to do is work on converting this. So I'm going to make this 10. Oops, let me get this thing going here. So 10 and something over 6. So I'm going to convert this 2/3 to be something over 6. Now this part over here, I'm not doing anything to that at all. It's already a 6, 7, and 5, 6. So I've determined that my least common denominator is 6. Both 3 and 6 will go into 6. 6 is the smallest number that both 3 and 6 will divide into evenly. That's what we mean by least common denominator. So 3 goes into 6 2 times. 2 times 2 is 4. So 2/3 can be written as 4, 6. So now these denominators are the same, but the problem now is you can't do 4 minus 5. You would end up with a negative number. So one way of dealing with this is to borrow. So what I could do is I could cross through this 10 and make it 9. I'm borrowing 1, but I'm borrowing 1 in the form of 6 over 6, which makes this 10 over 6. So I borrowed 1 from the 10 to make it 9, and then I'm adding 6 over 6 to 4, 6, which makes it 10, 6. And then over here, this part has not changed. So the benefit now is I can do 9 minus 7, which is 2. And I can also do 10 minus 5, which is 5. So this is 2 and 5, 6. So this is a good way of thinking about that problem with borrowing involved. So that's one way to do that. All right, let's take this mixed number problem and do it another way. So I showed you how to do it by keeping them as mixed numbers and getting a common term here on the bottom and borrowing and that sort of thing. A second way to do this is to change the mixed numbers to improper fractions. So 10 times 3 is 30 plus 2 more is 32 over 3. That was 10 times 3 plus 2, 32 over 3. And then I'm going to come over here and I'm going to do the same thing. 7 times 6 is 42, plus 5 will be 47 over 6. So I changed those from mixed numbers to improper fractions. Some people prefer this. Now I need these denominators to be the same. So what I'm going to do is I'm going to come over here and I'm going to multiply by 2 on the bottom and 2 on the top. That way this will be 6 and this will be 64, but I'll have a common term. So this is 6 and this is 6 now. So I'm multiplying by 2 over 2, which is essentially 1. 2 over 2 is 1, but it's a form of 1 that's going to give me a common denominator. So when I multiply there, 2 times 32 is 64 over 6, because 2 times 3 is 6. And of course, this is 47 over 6. And so now, because I have a common term here, 6, common denominator there, I can just I can not multiply, but I can subtract these. So 64 minus 47 ends up being 17. So 17 over 6, and that's the answer. Or you can change that to a mixed number. Well, 6 goes into 12 2 times. 6 times 2 is 12, and 5 more would be 17. So 2 times 6 is 12, plus 5 is 17. So 17 over 6 is the same thing as 2 and 5, 6. And notice that's the same answer we got here. This mixed number answer is the same answer we got in the previous portion of the video where I did it the other way. So 2 different ways of doing a mixed number subtraction. You can change them to improper fractions and do it, and then convert it over at the end. Personally, I like this way of writing the fraction over here better than mixed number, but sometimes people want you to write it as a mixed number. So 2 and 5 6 are 17 over 6. So that's the second way to do that particular problem.